where you are. With color music, you now have a kind of X-ray vision where you can see the energy that connects every note and interval. It's a bit like magic really, and gives you a major advantage. But it gets even better, because in this lesson, you'll discover the real nature of this energy and see that it's perfectly simple and symmetrical, and therefore predictable, so you can use it in your own songs too. What you will learn in this lesson. Here's a quick preview of what we'll cover in lesson 4. You'll see even more clearly how the colors match the patterns in music, perfectly and in every key. You'll gain a better understanding of how these patterns apply to the guitar fretboard so you can use them to your advantage. Using color, you'll explore the fundamental symmetry within and between keys to see how they're all interconnected. Finally, you'll learn how to advance with vision with a knowledge of how the notes relate in any configuration. You're on the right track. By now, you know this course is different than most, and in more ways than one. Obviously, it uses color, which is an advantage, right? Because it allows you to actually see how music works, so you can advance with ease. And this is definitely the best thing about color music. The insight you gain into theory, and therefore songwriting, which is really the whole point of making music in the first place. But this insight has a flip side that's also unique, and it's something that you may have already noticed, which is that because there's more to see in color music, there's also more to explain, making it more methodical than other methods, if you know what I mean. So as we've gotten into the finer details of theory, it may be moving at a slower pace than you'd like, at least in these first few lessons. After all, if this was any other course, you'd already be playing songs right now, strumming chords and crafting compositions, cutting to the chase for some more immediate gratification. So if you're feeling anxious at this point, I don't blame you, since your guitar gathered some dust in the last lesson. And you probably just want to skip to the fun part of actually making music already, like everybody else seems to do. But while that may feel like a shortcut, it's not. In fact, it would actually turn into more of a detour than anything else, taking you even further from where you want to be. Because in truth, you'd end up overlooking the most essential elements of music, meaning the underlying notes and intervals, which are what really inform the art of composition. And as a result, you'd remain blind to music theory with only a surface level view of things. Indeed, the only reason other methods move so fast to begin with is because they have to, since they really can't delve into theory anyway, even if they wanted to, in order to show how it works at the atomic level. So instead, they must start with bigger things like chords and progressions. Not really explaining them, of course, but using these patterns as the basic building blocks of a song, without getting any more granular than that. And while this gives the impression of producing audible results more quickly, it comes at a big price, because it gives you only a blurry sense of what really goes into making music. In this way, you could say that traditional learning methods are a lot like low-resolution images. Since they have less data, they're quicker to download, which can seem welcome at first. But really, all you get is a rough, pixelated image of music that can only be described as a poor depiction of what you're trying to see, compared to what's possible with color music, that is, which gives you the full picture, with everything manifest in visual high fidelity. Get it? Of course, it takes a little longer to download the more detailed image initially, but once you have it, you're better off because you know exactly what you're looking at. So stick with me as we walk through this lesson about scale degrees, which are the true building blocks of music. And in the next lesson, all of your hard work will pay off as you begin to play chords. You see, you really are on the right track here, and on the verge of more fun as we wrap up the first section of this course on the fundamentals of music. The less exciting, but absolutely essential stuff that everybody else overlooks. We're definitely laying the groundwork here for everything that is to come, so let's dive in deeper, shall we, into the most essential elements of music so you can truly build upon them throughout the rest of this course. Diving in deeper. To be sure, we've covered a lot in the last few lessons, but the main takeaway is this. In a nutshell, music is made up of 12 notes. And the relationships between these notes, that is, the intervals that connect them, are what inform the sounds you hear in any song. Easy enough, right? And now that you can actually see each interval, you have an advantage, because with color, you can follow their connections to navigate your way, tracking all the ties that aren't apparent in the traditional number symbols per se, but are obvious in the colors themselves. And as you've discovered, all of these intervals form a motley crew of characters in this play we call music, each with their own personalities that interact in different ways, like these in the key of C, for example. It's beautiful, right? How these relationships are now visible, since color and music follow the very same patterns. But when you look even closer, there's still more to see, because the colors and shapes illuminate other things too, down to even the finest details. For example, when you split the chromatic scale into its most basic elements of whole steps and half steps, the colors, squares, and circles continue to mirror these patterns with perfection. In fact, the match is so seamless that you can make sense of things much more quickly now by leveraging your familiarity with color to decipher the otherwise cryptic sequence of scale degrees. To illustrate, let's pick apart the key of C, and as you'll find, the colors and shapes reveal every possible connection between the notes, so you can understand every interval at even the most granular level. Basic intervals. In essence, the chromatic scale is made up of just two types of intervals: whole steps and half steps, which the colors and shapes emphasize by forming two sets of interlocking whole step intervals, where one set is all squares and the other is all circles. And as you can see, all of the squares align with the primary and secondary colors, while the circles include all of the tertiary colors. Get it? Whole step intervals. And since 1 is a red square in the key of C, this means that you can quickly spot all of the other scale degrees too, including intervals 2, 3, flat 5, flat 6, and flat 7, which are all evenly spaced within the squares, and intervals flat 2, flat 3, 4, 5, 6, and 7, which are shown as circles. You see? Both the colors and shapes correlate with the scale degrees, revealing simple and distinct patterns that are difficult to discern with the numbers alone, yet they're now apparent with the aid of color music. And when you look even further, you can see even more connections, like all the intervals spaced at 2 whole steps from each other, which form perfect triangles of primary colors: 1, 3, flat 6, secondary colors, 2, flat 5, flat 7, and 2 sets of tertiary colors, flat 2, 4, 6, and flat 3, 5, 7. Interesting, right? And further still, at a space of 3 whole step intervals, every note is positioned across from its polar opposite and complementary color, also known as a tritone interval, since it's 3 whole tones away. Like scale degrees 1 and flat 5 in the squares, as you already know, along with intervals 2 and flat 6, and 3 and flat 7, as well as numbers flat 2 and 5, flat 3 and 6, and 4 and 7 in the circles. Do you see what I'm saying? Half-step intervals. Likewise, you can see all the other intervals too, which includes some number of half-steps, mixing both squares and circles, like scale degrees flat 2 and 7 positioned on either side of 1, and scale degrees flat 3 and 6, each at an interval of 1.5 steps from 1, and intervals 4 and 5 as well, each spaced at a distance of 2.5 steps from 1, which form another pair of circles on either side of square 1. You can see all of these patterns, right? Because they're right there in plain sight. In fact, with color music, it's now impossible to miss the geometric symmetry of all these intervals too, which again reveal the fundamental simplicity of music that's otherwise masked by the asymmetrical appearance of the numbers alone. Numbers that utterly fail to convey the elegance of these geometric connections. Later in this lesson, we'll explore the significance of these intervals, but now that you can see their symmetry, you know they'll be a lot easier to understand, right? And that's largely because this same symmetry applies to the other keys as well, since every key follows the same pattern. So once you see these relationships in one key, they're immediately visible in all 12. Like in the key of G, for example, which has all the same scale degrees, but with the numbers in new positions since G is labeled 1. Get it? In the same way, the colors guide your eyes and mind to make sense of all the intervals, revealing the perfect symmetry that exists within this key too. And when you shift the scale degrees to highlight each new key, the patterns shown in the colors and shapes remain consistent, as you can see here in the keys of D, A, E, B, G flat, D flat, A flat, E flat, B flat, and F. In each key, the scale degrees shift, but the underlying intervals remain the same, which is cool, right? So in effect, the notes in each key tell the same story, since all were equally affected by the rotation from the circle of fifths to the chromatic scale, of course. And as a result, the same patterns can be found in each one, so that all 12 keys are buzzing with a variety of relationships, all intertwined to form a super pattern of sound that's full of energy and potential, where any combination or sequence can set off a string of inspiration. So let's dive in even deeper, shall we, and dissect these connections in the chromatic scale, so that you really know this pattern intimately, in order to use it to build any note pattern you'd like. Though first, be sure to test what you know so far by completing the first quiz and set of exercises. Dissecting each key. To recap, what you've learned so far is that music is all about relationships. Visible relationships, it turns out, that you can clearly see with color. And as luck would have it, these connections are perfectly symmetrical too, which are divided into 6 basic patterns, where 3 of them, shaded in gray here, are made up of all whole step intervals, including sharp 4/flat 5, 3 and flat 6, and 2 and flat 7. And the other 3 are built from half step intervals, including 4 and 5, flat 3 and 6, and flat 2 and 7. You see? Together, all of these patterns are a beauty to behold, right? Since they form such an interesting array of geometric lines and color. But what's even better is the actual utility of these patterns and the sounds they produce, which really are wonderful. So over the next few images, we'll pick these patterns apart to understand how each interval functions, and to see and hear them all on the guitar. And in the process, we'll inspect each one in 3 different ways. First, in a circular format to see the cyclical symmetry between all 12 keys, then in a linear sequence to dissect the symmetry found within each separate key. From top to bottom, this table illustrates the major scales in the order they appear within the circle of fifths, C, G, D, A, etc. And finally, laid out on the fretboard to explore the practical application of these patterns on the guitar. Of course, all 3 of these configurations are just different iterations of the same patterns, but each perspective provides its own special insights. So by putting these views together, you can essentially form a composite mental image that gives you the full picture. In the same way Leonardo da Vinci always drew his anatomical studies from 3 or more angles to truly understand the nature of his dissections. Get it? So as we move through the next few images, pay attention to each pattern, meaning the circular, linear, and grid-like depictions of the notes and intervals, because they're all important. Though really, the last one is the most essential, since it illustrates how these patterns apply to your actual instrument. And because skill and experience come from actual practice, I've also included diagrams of every interval pattern on the guitar in every key for you to play, hear, and really master these relationships for yourself. So be sure to play each pattern as you go, to supplement your head knowledge with hand knowledge, because that's really the best way to learn. Though before you jump in, I should mention one thing, which is that I don't expect you to memorize everything you're about to see here, at least not on your first pass. In truth, learning about intervals and playing each of these patterns on the fretboard is a bit like learning to play chess, which can be a lot to take in when you're new to the game, with all the pieces scattered across the board. So to break things down, it helps to first isolate the individual movements of each piece, dissecting the game one layer at a time so you understand all the component parts on their own, as you can see here. So when you put all the pieces together again, you can wrap your head around how the game is played. And the same is true for music theory. As with chess, it helps to dissect its various patterns into layers, so that when you combine all the elements once more, you sound like a damn genius. Get it? It's all the same basic idea. In this way, you can think of the fretboard as a kind of chessboard, only it's even better because all the game pieces are baked into the board itself, where you don't slide a king or a queen from one position to the next, but move your fingers from string to string and fret to fret, following the patterns that are plotted on the guitar, fully engaged in the process of composition, which is also a game of strategy, logic, and inspiration. So follow along and play each pattern, one at a time in each and every key. For each diagram, start at interval 1 in any spot on the fretboard, then pivot from there, moving your fingers left, right, up, or down to reach the other intervals shown and to get a feel for the distance between them. Then keep moving through this lesson, and in lesson 5, you'll really start to put all of this theory into practice when you begin to build chords. And by the way, you'll find full-sized versions of all of these diagrams in the lesson PDF. So check those out to play through and hear each of these patterns at your own pace. Sharp 4/flat 5. Possibly the most distinct interval is the one between scale degree 1, also known as the tonic, and sharp 4/flat 5. Like I said before, this interval is sometimes called the tritone because it's spaced 3 whole tones from the tonic. These intervals are complementary colors or polar opposites and sound dissonant or incompatible together. In fact, you could say the tritone is the yin to the tonic's yang. Here's what they sound like in the key of C. And the same pattern appears in all the other keys as well, which I'll show next, although we'll just flash through them for you to see. But take your time in the PDF to play each pattern and really listen to how these intervals sound in each key. C, G, D, A, E, B, G flat, D flat, A flat, E flat, B flat, F. To be sure, none of the patterns you just played sounded very good per se, since tritones are so dissonant, but that's not the point right now. The real purpose of this lesson is to learn the layout of the fretboard and to build muscle memory as you get a feel for the spacing between notes. So be sure to play each pattern as many times as you need to. And as you go, you might also notice some interesting things about these intervals, like the fact that some of the same relationships are repeated in different keys, since each pair of tritones has a mirror image. For example, can you see how keys C and G flat are basically the same pattern of complementary colors that form a pair of polar opposites? And did you notice this connection between keys G and D flat, D and A flat, A and E flat, and the others too? It's pretty cool, right? And as a result, you can start to see how these intervals aren't really as varied or complex as they might seem at first, which is wonderful. And as you look at the other patterns, it actually gets even better. 4 and 5. Intervals 4 and 5 are also easy to spot in any key. These notes are clearly related to the tonic since they were close neighbors in the circle of fifths. Both intervals are also part of their key's major scale, so they sound very good or consonant with their tonic. In fact, they sound so good they're sometimes called the perfect fourth and perfect fifth, or subdominant and dominant respectively. Here's what these scale degrees sound like in the key of C, for example. And again, these same intervals appear in all the other keys as well, so be sure to play these at your own pace in the lesson PDF. C, G, D, A, E, B, G flat, D flat, A flat, E flat, B flat, F. Once you play these patterns, did you notice anything special about them? Unlike the tritones, each group of 1, 4, and 5 notes sounds more consonant, since they were all close friends in the circle of fifths, so they're definitely more pleasing to the ears and more fun to play, right? But just like the tritones, there's also a pattern to the way these patterns relate, which is that each set of tonic, subdominant, and dominant notes has a mirror image, resulting in 6 pairs of opposite patterns like this. So just like before, and as you'd expect, keys C and G flat form a pair of opposite keys, as do keys G and D flat, and keys D and A flat, etc. Nice, huh? So again, you can see that all of these patterns have certain similarities, which help you to reduce them all to a more manageable group that can be easily understood. 3 and flat 6. Intervals 3 and flat 6 are also evenly spaced from the tonic 1. Musicians call them the major third and minor sixth intervals respectively. The major third is so called because it's in the tonic's major scale, so it sounds especially consonant in a key. It's also sometimes called the mediant. The minor sixth, however, isn't in the major scale, so it doesn't get as much play in a given key. Here's what these scale degrees sound like in the key of C, for example. And again, these same basic intervals appear in all the other keys as well, so play these in the lesson PDF to hear how they sound. C, G, D, A, E, B, G flat, D flat, A flat, E flat, B flat, F. Major third and minor sixth notes sound interesting, right? And because each one is equally spaced around the tonic note, they form a very recognizable pattern of colors. But did you notice anything else about the patterns you just played? If you look and listen closely, you'll observe a special connection between different keys due to the spacing between these intervals. Specifically, since each group of 1, 3, and flat 6 notes forms a perfect triangle, these same simple polygons are repeated in various keys, so that really only 4 basic patterns of major thirds and minor sixths emerge. Do you see what I mean? It's beautiful, really. And now you can see even more how all the keys form an intricate array of perfect geometric symmetry. flat 3, and 6. Intervals flat 3 and 6 are both very popular. Musicians call them the minor third and major sixth intervals, respectively. The minor third is so called because it is not part of the major scale, but the major sixth, or submediant, is in the scale, hence the name. Both intervals are somewhere between consonant and dissonant. That's because both are also evenly spaced with interval #4/flat 5, creating a kind of dual affinity between the tonic and its tritone. Intervals flat 3 and 6 also form a pair of tritones in their own right, giving them a haunting sound. In the key of C, for example, the tonic 1, flat 3, mediant 6, and tritone #4/flat 5 form a square of evenly spaced notes, two pairs of intersecting tritones. Here's how they sound in the key of C, for example. And here's a look at these same scale degrees in each key, which you can hear for yourself as you play through each pattern in the lesson PDF. C, G, D, A, E, B, G flat, D flat, A flat, E flat, B flat, F. In any key, intervals 1, flat 3, and 6 sound good, right? But in a different kind of way, where the tone they create is dramatic, a bit tense, and even melancholy. Since, after all, these intervals share some dissonant connections formed by two pairs of tritones that intersect to make a perfect square. And because each of these squares is symmetrical, you can see how some of the keys share the same set of notes, all spaced at the same intervals like this. It's awesome, right? And as you'll see next, there are even more intervals that break the chromatic scale into clear and recognizable patterns. 2 and flat 7. Intervals 2 and flat 7 are known as the major second and minor seventh, respectively. The major second, sometimes called the supertonic, is in the tonic's major scale. It's also closely related to the perfect 5 note, so it shares a certain affinity for the tonic. The minor seventh isn't in the major scale, but because it's closely related to the perfect 4, it also has a special bond with the tonic. You'll often hear both of these intervals in a lot of music. In the key of C, for example, the tonic 1, supertonic 2, and flat 7 are all part of a hexagon of whole step intervals. Here's how these intervals sound in the key of C as an example. And this is what they look like in the other keys, which you can play and hear for yourself in the lesson PDF. C, G, D, A, E, B, G flat, D flat, A flat, E flat, B flat, F. Intervals 1, 2, and flat 7 sound good in each key, right? And since they're all evenly spaced whole step intervals, they're also easy to play, because all you have to do is press every other fret on a string and the sequence unfolds. And of course, just like all the other patterns you've seen so far, these intervals also highlight some similarities between the various keys, like the fact that 6 of the keys with the square-shaped tonic are linked by a hexagon of whole steps, as are the keys with a circular tonic too. Do you see what I mean? Once again, the colors reveal the simple geometric connections that exist between keys based on the intervals they share. And as you'll see next, this same powerful symmetry extends to intervals flat 2 and 7 as well. Flat 2 and 7. Intervals flat 2 and 7 are known as the minor second and major seventh, respectively. The minor second isn't part of the major scale pattern, but the major seventh, or leading tone, is. Yet both of these intervals sound fairly harsh and dissonant with the tonic. That's because both intervals are closely related to the tonic's tritone, #4/flat 5, in each key. And these intervals flank the tonic because of the rotation of notes that forms the chromatic scale, as you saw in lesson 3. In the key of C, for example, the tonic 1, flat 2, and leading tone 7 are part of a 12-sided dodecagon of half-step intervals. As an example, here's what these intervals sound like in the key of C. And here's what they look like in the other keys too, which you can play and hear in the lesson PDF. C, G, D, A, E, B, G flat, D flat, A flat, E flat, B flat, F. Together, intervals 1, flat 2, and 7 form probably the simplest pattern possible in each key. As a plain sequence of half-step intervals, these notes are easy to play just by sliding your hand up or down a string, one fret at a time, which also happens to sound fairly dissonant as well. And because all 12 notes form a series of half steps, you can see that the entire chromatic scale is basically a pattern of flat 2 and 7 intervals, all linked by a 12-sided dodecagon like this. Get it? It's cool, right? In essence, this same relationship between the tonic note, 1, and intervals flat 2 and 7 in one key is the same in all the other keys, just like the bonds between the tonic, 1, and each respective scale degree, as you've seen previously. And because these relationships are symmetrical and geometric, it's easy to see how every key works, that they're all divided into 6 basic patterns and are totally intertwined. To recap, these 6 basic patterns are sharp 4/flat 5, 4 and 5, 3 and flat 6, flat 3 and 6, 2 and flat 7, flat 2 and 7. When you look at it this way, it's impossible to miss the elegant simplicity of music and the fact that it's a very structured and logical art form, all built upon a beautiful framework of intervals that are consistent in every key. An intricate network of connections, that is, which links every note in every key, and that extends beyond the basic relationships of the major scale that you learned about in Lesson 3. But now that you know the essential symmetry of these patterns, let's organize them in a way that makes even more sense, so that you can really use them to your advantage as you play the guitar. And that is to arrange them all by their respective keys, as you'll see next. But first, be sure to take the next quiz and play each exercise. Scale degrees in every key. By now, you know that music is all about patterns, some seriously cool symmetrical patterns at that, which connect every key and reveal how they're all built in the same basic way. But while these patterns have been insightful so far, the next step is to make them more practical by organizing them by key now, which is how they're really used in music. So practice playing these patterns in each key, starting at the tonic and then moving to the other intervals shown to get a feel for the distance between them and the sounds they produce. And you'll definitely be a huge step closer to mastering the guitar, since these intervals serve as the building blocks of the patterns you'll learn throughout the rest of this course. Again, you'll find full-size versions of the following diagrams in the lesson PDF. And here, I'll just flash through the patterns one at a time in each key so that you can see them. But be sure to play through each interval pattern at your own pace in the lesson PDF, so again, you hear how they sound in each key. Take your time to really absorb the patterns. The key of C. Sharp 4/flat 5, 4 and 5, 3 and flat 6, flat 3 and 6, 2 and flat 7, flat 2 and 7. The key of G. Sharp 4/flat 5, 4 and 5, 3 and flat 6, flat 3 and 6, 2 and flat 7, flat 2 and 7. The key of D. Sharp 4/flat 5, 4 and 5, 3 and flat 6, flat 3 and 6, 2 and flat 7, flat 2 and 7. The key of A. Sharp 4/flat 5, 4 and 5, 3 and flat 6, flat 3 and 6, 2 and flat 7, flat 2 and 7. The key of E. Sharp 4/flat 5, 4 and 5, 3 and flat 6, flat 3 and 6, 2 and flat 7, flat 2 and 7. The key of B. Sharp 4/flat 5, 4 and 5, 3 and flat 6, flat 3 and 6, 2 and flat 7, flat 2 and 7. The key of G flat. Sharp 4/flat 5, 4 and 5, 3 and flat 6, flat 3 and 6, 2 and flat 7, flat 2 and 7. The key of D flat. Sharp 4/flat 5, 4 and 5, 3 and flat 6, flat 3 and 6, 2 and flat 7, flat 2 and 7. The key of A flat. sharp 4 slash flat 5, 4 and 5, 3 and flat 6, flat 3 and 6, 2 and flat 7, flat 2 and 7, the key of E flat, sharp 4 slash flat 5, 4 and 5, 3 and flat 6, flat 3 and 6, 2 and flat 7, flat 2 and 7, the key of B flat, sharp 4 slash flat 5, 4 and 5, 3 and flat 6, flat 3 and 6, 2 and flat 7, flat 2 and 7, the key of F, sharp 4 slash flat 5, 4 and 5, 3 and flat 6, flat 3 and 6, 2 and flat 7, flat 2 and 7. The symmetry of rolls. I've said it before and I'll say it again. All of the patterns you just played are important. And though they might not be the most exciting things you've ever heard, you'll be glad that you know them now because they serve as the very foundation of music theory after all, and therefore the basis of songwriting too. In fact, now that you know the essential elements of each key, meaning all the notes, every interval, and the relationships between them, you are now poised for greatness. Truly. But before we wrap up this lesson and move on to the next, I want to emphasize one more point, which is something that I've mentioned before, but that you can now clearly see for yourself. And that is that you ultimately don't need any of the scale degree labels that we've used so far, like intervals 1, flat 2, 2, etc., because none of these numbers are the actual intervals anyway. In reality, each interval already exists on its own, independent of these standard symbols, ever present whether explicitly labeled or not. And once you can see this, you really are empowered in an unprecedented way to see, really see, all of the relationships that are at play in music and that make songwriting possible. For example, as you've seen in each key, the same ties persist between intervals no matter what you call them, like the bond between, say, C and G. In the key of C, these intervals are labeled 1 and 5 respectively, and they sound especially good together because of their close connection in the circle of fifths. In the key of F, however, these intervals are called 5 and 2 instead, but they're still just as consonant because of their close proximity in the circle of fifths. In the key of B flat, however, the numbers again change to 2 and 6 respectively, yet the relationship between them is the same due to their unchanged history in the circle of fifths. And likewise, when you rotate the scale degrees through all the other keys, this same consistent tie can be seen. Get it? It's really quite simple when you can literally see this connection with color. And of course, the same is true for all the other intervals as well. To illustrate, this image is a concise summary of how the scale degrees change from one key to the next, starting with the key of C at the top and then cycling down through the key of F at the bottom. And though the numbers clearly shift as you go, all of the intervals and relationships remain the same. You see? It's beautiful, right? And this point will definitely come into play when you build chords and craft melodies in later lessons, because all of these patterns are based on the same underlying relationships, which you now know are stable and consistent. And with this stability comes a level of confidence, since you'll always know the elements that you're working with. Indeed, now that you know the intervals between notes are predictable and constant, you can trust that the notes themselves are reliable too. So no matter what role a pitch might play in relation to the others, its identity stays the same. For example, it's now forever obvious that C is always C in every key, in the same way that, say, Bob is just Bob, despite any change in his social group or setting. In his family of origin, this fellow might play the role of son or brother, while his extended family might call him uncle or cousin, and his own kids just think of him as dad. But no matter the circumstance or group, his identity is unaltered. You get what I mean, right? And just as it is with people, the same is true for every note in music. In fact, if you repeat the diagram we looked at a moment ago, and then zoom out a bit, an interesting pattern emerges, as you can see here. Or at least I should say that a pattern appears, although it's still difficult to see here, until you focus on only a portion of this image, that is, like this. And what you find is that each interval cycles through different number labels in each respective key, all shifting through the same sequence of scale degrees in turn. You see? Actually, this is even easier to see in the full-size image found in the lesson PDF. And as a result, each note is labeled with a different number and plays a different role depending on its position within a given key. Though of course each note remains the same. and the connections between them stay intact and predictable. So while I've compared the notes to people and all the intervals to their relationships, this analogy only goes so far, because this cyclical nature of music ultimately defies the linear sequence of human genetics, since one person could never really be the son, father, and grandfather within a single family, in the same way a note can cycle through the roles of 1, 4, and flat 7 in various keys. Get it? That would simply be impossible, and would otherwise turn into just another crude joke about incest, where your dad is also your cousin and brother. And as a result, music stands as a kind of anomaly, like a symmetrical superfamily of androgynous entities, all without any X or Y chromosomes to speak of, but very much alive in their own special way. Advancing with vision. Now, of course, I know this might sound strange and even fantastical. The idea that music is comprised of asexual superbodies all abuzz in a network of energy that's palpable and real. But it's true. And now that you can see this all yourself, you know it too, for sure. You can clearly see each note, every interval, and all the connections as plain as day, and you don't have to run any mental calculations in the process. For example, there's no need to subtract the numerical difference between any two scale degrees, or to measure the alphabetical distance between letter names, because the colors and shapes inherently communicate all of this. At any given point and in every configuration, you can immediately see the bonds that are at play in a pattern, at a glance and without the need to take more Advil for that pounding headache. It's wonderful. And as we advance through this course, you'll continue to see how truly wonderful this is, because now that your mind is unfettered, you can easily understand note patterns as they appear in any formation, whether shown as a cyclical pattern, or laid out on the fretboard, or plotted in music notation, or depicted in a chord diagram. Whatever the context might be, and no matter how the image is arranged, you'll be able to absorb what you see, directly and with absolute clarity. Which brings us back to the beginning, to the very start of this course when everything was invisible and the guitar seemed so confusing. Yet all you really wanted to do was just play the instrument and make some music already. Well, now that you've cracked the code to music and the fog has lifted, you're ready to move on to the fun part of actually doing this by playing chords. And as you'll see next, it's all very simple, since chords are built from the same basic patterns you learned about in this lesson. So be sure to complete the last quiz of lesson 4 and go through each exercise. Then join me in lesson 5, where it all gets even more interesting.